Hello guys, welcome back. In my last tutorial, I have explained to you how to use priority queue. Now this tutorial, I'm planning to explain to you how you can use priority queue in a real life situation. So if you look at my screen, I have written some example code to take you through the real life scenario. If you concentrate on line 9 and 10, I have written a class called transmitter, which is printing a string every 500 millisecond, and I'm running the transmitter code in a separate thread. So let me run this program so you can understand what transmitter class is doing. So as you can see, transmitter class is transmitting this line called transmitted with hello and some integer number. So you can see how many packets being transmitted. Let me stop this program and clear the screen. So let's say we would like to write a program which receives transmitted data every 500 millisecond. So let me uncomment my mockup code. What I'm doing in this code here is every 500 millisecond I'm polling this function called receive.receive, and every time it executes this function it will try and read what transmitter has transmitted and then print it out on the screen, and thread.sleep, which will allow me to have a consistent 500 millisecond gap in between. So let's see what it does. So if I execute this program, and let me stop it. So as you can see on the screen, basically transmitter transmitted hello 0 and receiver received hello 0 and 1 and 2 and so on. So basically now the program is happily running. Everything that is transmitted is received by this program, and purely because transmitter is transmitting at 500 millisecond rate and receiver is receiving at 500 millisecond rate. But that's not how real life scenario works. So let me clear the screen first and then we'll talk about more. So what do I mean by this is not a real life scenario? So because my program is very simple and it is specifically designed to show you how transmit and receive works, I have controlled every variable carefully, so when you see the printout it is nicely like receive and transmit are all in sync. But that's not how real life works. In real life, because you will be doing a lot more than what I'm doing on my program, and plus computer CPU usage and all the other variables taking into place, your program might not be receiving or transmitting things exactly at 500 millisecond apart. So there is a possibility that you would go out of sync and not receive some packet or transmit it too early or receive it too late or things like that. So just to show you how real life scenario works, let me make these sleep to 1000 millisecond. So what am I doing here is I'm transmitting still at roughly 500 millisecond, but I will only be receiving at every 1000 milliseconds. So assume that your program gets busy every now and then you only get chance to receive something at 1000 millisecond. So let me see what will be the end result. So let's run this program and let's stop now. So as you can see, the first transmitted hello 0 was received by receiver very happily. Then transmitter got opportunity to transmit hello 1 and 2, but receiver only managed to receive second response. And again like 3 and 4, but receiver only managed to get 4. So receiver, because it gets busy doing other things, it's keep missing one packet every time. So real life scenario is exactly like that. In real life, your program might get busy doing other processes, and then in the meantime, if someone has fired 2 packets at you, you will miss some, and that is not the good place to be. So let me clear the screen again. So let's talk about reality. So there are 2 facts that we have to accept before we can think correctly. So the one fact is that our program will always can get busy and do other things. So we can't always rely on thread.sleep kind of function to do the right thing. And the second fact is the transmitter. Even though I'm currently controlling the transmitter, it is possible that transmitter is written by someone else or it is running in a separate PC, and you have no control over transmitter, so you can say, transmitter, please do not transmit until I become free again. So accepting these two reality, now we have to think that how do we write our program so that we do not miss any transmitted package, but at the same time we can go and do other things. So let me show you that how can this be achieved by using priority queue. So let me comment out our existing receiving code, which is not the correct way to achieve this, and let me uncomment the code that I've written using priority queue. If I format it, now let's go through line by line to understand how it is implemented. Okay, so the first line is just creating a priority queue object. I have named the object queue, and I have defined that I would only receive a string kind of objects, so all we can inject in the queue is just a string type of objects. Now what is these two line does is it creates the another thread and call these class object called receiver with a queue. Let me show you what does that do. So let me scroll down to the class receiver with queue. Receiver with queue implements runnable, and also you have seen keyword like thread. In this tutorial I'm not going to explain to you what thread and runnable and implements all these means. If you would like to know, you can wait for my future tutorial, or you can Google it for now. But basically what we are trying to achieve here is we want the class that we can run it in a separate thread, and it does the receiving for us. So if we look at these first three lines here, this is a constructor for this class, and it allows me to pass the priority queue object that I have created in my main thread. And this run function is basically running the while loop. So every 10 millisecond it is running this while loop and calling the receive function that we used to use in our previous way of doing things. And if it sees that it received something from the transmitter, it will add to the queue by using function called queue.offer. And if it finds that receiver didn't receive anything, which is in our case null, it would not do anything. Now thread.sleep, I have chosen 10 millisecond sleep. Now you need to be careful here because transmitter is transmitting at 500 millisecond right now, and the general law is that if you already know your transmitter speed, you should be at least 2 times faster than the transmitter speed to guarantee that you would not miss any packet. So just to give you an worse example, so if you are transmitting at 500 millisecond and if you keep your receive while loop also only polling at every 500 millisecond, then there is a chance that you are just on the edge of that 500 millisecond and you might miss that packet. So generally you want to be 2 times faster. Now in my case I have made it 10, which is way faster than 2 times, so obviously it's safe to do so. Now you don't want to have no sleep here at all, because otherwise while loop will just run it as fast as it can, and then it will not give other thread opportunity to do their thing. So you definitely want to have some sleep here, but you have to always find the right balance based on the kind of program you are writing. So basically this class is just receiving stuff at every 10 millisecond, and if it receives something it will put it in the queue, which we can access from our main thread. So let's go back to our original program. So basically what I'm doing here is I'm creating a new thread and I'm creating the object of the receiver with queue class. I'm passing my priority queue object into that class, so then it can populate the queue as packets are received. I have written another while loop which is very similar to the one we used to use before. The only difference is the previous while loop was using the receive method directly and these function uses the queue instead. So it will pull the first object from the queue every time it runs this while loop. Now the difference is that when you do queue.poll, because queue have preserved all the object and the sequence that object was populated into, we will not miss any packets like we used to before. So let me execute this program so you will understand. I have still kept the thread.sleep to 1000 millisecond just to represent that our program can go and do other thing and get busy for 1000 millisecond. So let's execute this program. So if I stop it, let's see what is happening here. So the very first time receiver queue received nothing, so it just printed empty. Then transmitter started doing its thing, so transmitter transmitted 3 different packets, and because we were busy sleeping, we obviously did not receive it fast enough. But now that we are using queue, when we ask queue to give us very first element, it did give us the first element. In the previous while loop, we only received the hello 2 because when it tried to receive something, transmitter has already transmitted 2 packet which you have missed. But now with the queue implementation, you are always receiving the packet in the same sequence, so we don't ever miss any packets. Yes, we will process them later, but that is still safer than not receiving packets at all. Now another important thing to understand here, that because you are always processing data slower than transmitter transmitting the data, eventually your queue will run out of space. So you always have to find the right balance on how fast to process things. Even though in my program I have hard-coded 1000 millisecond sleep, generally that's not the case. Sometimes program gets busy, but sometimes program gets more time to process it. So in real life scenario, you would process queue at much faster rate than what I'm doing here. And as long as you know that your queue would not be flooded with all the transmitted data, you are writing a good program. So there you go, guys. You now know how to send and receive data using the priority queue. There are many different ways you can use queue implementation. So this is just the one example, but if you have any question, you can put a comment in my YouTube channel. Thank you for watching, and please subscribe to my channel. See you later.